Okay. All right. Yeah. Good afternoon, everyone. My name's Jason Caro. So I'm here to talk about PageTurn. So AI production systems, as we know, don't read books like humans. They read books like computers with something called retrieval augmented generation, or RAG for short. So the RAG paper first came out in May 2020. It was by Patrick Lewis, some other folks at the Facebook AI team. And they tested fusing a language model with a knowledge database. I think it included Wikipedia and some other sources. They had really good results. For knowledge-intensive tasks, the RAG system outperformed models by themselves. And since that point in 2020, the industry has been moving towards RAG systems with AI. So what does RAG system actually look like? So this is not what it looks like. This would be a classic question, action, or task that passes directly to a chat model. Rather than do that, we query a database. And so this is kind of what the database looks like. We pull out these chunks, these white little documents at the bottom, and we put the entire thing together and produce an answer with contextual information. So I'm not going to explain everything on this chart, but I would like to focus on this part right here. So, the question, how do we get the contextual chunks? How do we get these documents? So there's like many techniques. We can use keyword algorithms. We can use Boolean queries. And then, of course, vector similarity search is the most popular, and for good reason. But what I'd like to do is just today lump all these together and think of them as basically a control F function. So similar to the control F we use in our daily computer use, that is the analogy we will stick with, and we'll revisit that paradigm later. So meet Bill. Bill is an AI tinkerer. Bill lives in Austin, is a mid-career developer who stays on the cutting edge of his field. So of course, his RAG stack is using the latest tools from LangChain, splitting text, looking at the embedding model leaderboard on Hugging Face, and using things like the parent document retriever released by LangChain less than a month ago. And so his RAG system, unsurprisingly, performs incredibly well. And he's currently building a RAG system for a local rocket company in Austin. Some say it will be the next SpaceX, but he's noticing problems. Reliability is like plateauing at 85 to 90%. And he's realized incomplete retrieval is the culprit. Let's jump into Bill's problem. So, for example, he's seeing like a user query. What formula do I use to calculate aerodynamic drag force? So great. We query our vector database. We get these incredible high cosine similarity score results. For example, I'll read the bottom one. It says, the last sentence, the aerodynamic drag force acting on a vehicle while moving is approximated by the formula, colon. But where is the formula? That's our problem. So if we look at like the original source text, it's pretty common technical document. It's got a small definition of kind of setting up this formula. It has some information at the bottom. This is great semantic similarity. And our vector search gets hits on that information, but our formula is left stranded in the middle. So what is the solution? Well, what is the problem first? Semantic similarity does not always equal relevance. That is the key. Semantic similarity does not equal relevance. So the solution, introducing PageTurn. PageTurn is a framework and foundational model system for helping AI determine when to turn the page, either forward or backward. So let's look back at our example. So we see we got these chunks. They were, great hits. So now we have these two documents. Well, let's pass these documents on to PageTurn. PageTurn looks at the chunks, looks at the documents, and decides it wants to see more. It decides to turn the page. And so what do we get? An extra piece of contextual information related to one of these chunks. And we are able to get the formula we were looking for. So what we want to do is break free from the Control F paradigm. And we want to break free from the tyranny of the chunking system we use, the predefined chunks that we cannot get away from. We want to go to an experience that's a little bit more like the human reading experience and roam around and find the information we need using some AI intelligence. So let's see. Demo. I'm gonna share a new screen. Are y'all able to see my screen?
Yes, we can see the screen. Just says demo.
It says demo. Okay. Well, that's not the right one. Let's see. This is the part of my demo I did not expect to break, just the screen share. So let me see here. Here we go. Okay, can you see the chainlet?
Ready to go.
Perfect. So let's query this. I want to know the formula for arrow dynamic drag force. Let's see what happens. Okay, you can see using PageTurn. All right. Okay, we got a formula. So let me jump back to my other screen and we can finish out. The demo has been successful. Can y'all see the slides now?
Yes.
Perfect, thank you. Yeah, so I guess I'll just end the talk just on a reflection. So thinking about our current AI systems, they are amazing. They take millions of lines of information in the form of numbers, and we're able to query them at the speed of computation. And all of this lands at the feet of the most powerful reasoning engine humanity has ever built, the LLM. And this is great. This is incredibly powerful, but I'd like us to just imagine if our system architectures just had the freedom to intelligently explore horizontally and roam around a little bit. Perhaps our systems could get a little bit more creative, a little bit more coherent, and break free from the current paradigm we have. So PageTurn, the roadmap looks like, some pull requests for LangChain Llama Index, mostly like some prompt engineering with like current off-the-shelf models, eventually training our own models that can, solve this problem. And then PageTurn as a service, PTAS, would be the goal. If you're interested in following, please go to pageturn.io, sign up for updates. And that's it.